In this video, we're going to take a look at the fundamental identities that we use for our trig functions. We're going to start building a library of identities and using them to solve some trig problems, but also to verify other identities. We're going to kind of use this as a basis to build on. Okay, well, let's get started. Some of these we've been talking about since the beginning of the semester, so they will not look new to you, but I'm just going to go ahead and jot them down anyway. So the first one that we have is the reciprocal identities. And so these are the cosecant of theta is 1 over sine of theta, or I guess we could have used x, but I went ahead with theta today. The secant, we know that's 1 over the cosine, and the cotangent is 1 over the tangent. All right, we also have what are called the quotient identities. These are for a tangent and cotangent. So we know that tangent is the sine over the cosine. And we know that the cotangent of theta is, it's the reciprocal of that, which means we're going to have the cosine over the sine. Okay, beyond those, we also have what are called the Pythagorean identities. These are based on, we could draw a triangle on the unit circle. We've done this in the past, but let me go ahead and do that really quick. I'll just do it right here. So let's say we had the unit circle, which means the radius is 1. So if I were to pick a point on the unit circle and kind of drop a perpendicular here, right, this point, the x value would be the cosine of the angle. I'll keep using theta, and the y value would be the sine of the angle. And so this is sort of acting like the x, and this is acting like the y, and the x would be this side of the triangle, the y would be this side of the triangle, and since it is the unit circle, the radius or the hypotenuse is 1. Okay, so that's all of that to say that if we were to use Pythagorean's theorem, right, for this triangle, we'd have x squared plus y squared equals 1, but x is the cosine and y is the sine. So the first Pythagorean identity is cosine squared of theta plus sine squared of theta is equal to 1. And that's all based on this unit circle. Okay, there's actually 3 versions of the Pythagorean identities. I only remember the first one, and then I used this one to derive the other 2. And it's all based on taking this and dividing each part by either cosine or sine. Okay, so the next one, let's do it dividing by cosine. Okay, so if I'm not going to write it out because I don't have enough space, but if I were to divide this by cosine squared divided by cosine squared would be 1. Sine squared divided by cosine squared would be tangent squared. We're kind of using the identities we just wrote down up top as well. And then 1 divided by cosine squared would be the secant squared. Okay, the third one is we're going to use the same process. We could take the original and now divide by sine squared of theta. So let's do that. So cosine squared divided by sine squared we just wrote this down, would be the cotangent squared. Sine squared divided by sine squared would be 1. And 1 divided by sine squared would be the cosecant squared. Okay, so those are the 3 Pythagorean identities. All of the identities that we've mentioned so far are the ones that I think that you should be able to memorize for the next tests. Let's see if we can fit them all on the screen. So all of these, how many is that? 3, 6, 7, 8. All of these 8 identities, I would recommend that you memorize these. We are going to get some others. Like we said, we're going to build a library upon this, but I feel like these are the ones that you could commit to memory and it would do you well. Okay, there are a couple more mentioned right here at the beginning. So the next one works with the idea of an odd function versus an even function. So an odd function, I'll just write this at the top, to the side, right, has symmetry around the origin. Which means if I take the graph and I rotate it around the origin 180 degrees, I should get the same shape. When I think of this, I always think of x cubed, which has a shape that looks like this. So for an x cubed, if I plug in a positive, I get a positive. I plug in a negative, I get a negative. And that's a big part of this, and it's going to drive the identities we write down after. But also, if I rotate this or completely turn it upside down, I'm going to get the same shape. An even function has symmetry over the y-axis. And I always think of the parabola when I think of y-axis symmetry. This is the kind of symmetry that says I can cut it down the y-axis and get 2 equal parts. So an even function is able to do that. I have, whether I put in a negative x or a negative x or a positive x, I'm still going to get the same y value when I do that. And so that's kind of what's driving these identities, and it's all based on that type of symmetry. Okay, so if you think about the graphs that we've been graphing, right, the ones that are odd, that have this type of symmetry, are the sine and the tangent. So if I calculated the sine of negative theta, if I change the sine of theta, I'm going to change the value of the sine. If I put in a negative x, I'm going to get a negative y out. It's kind of like that idea. It may not be exactly a negative x producing a negative y, but a negative x is going to change the sign of the y value. If it's true for the sine, it must also be true for the cosecant, right? Because those two are cofunctions and they kind of follow the same patterns. So we said it's true for the sine and it's also true for the tangent. You could definitely try this out. Right? Pick an angle that you know about, and plug it in and try it, and it's definitely going to work. Use your calculator to help you. You can match this up with the graph. There's lots of ways to kind of confirm that this is true. Okay, the function that's even is the cosine, which means that even if I change the value of x, if I change its sign, it's not going to affect the y value that I get out. So if I put in a negative angle or a positive angle, I'm still going to get the same value for the cosine. And whatever the cosine does, the secant does, because they're co-functions. All right, so we have one problem that this type of problem we've done before, and we used a unit circle and a triangle, and now we're going to use the identities. So actually, I'm going to pull this under. This is actually going to make use of the Pythagorean identities, so maybe we could keep those close. So it's from your book. It says use identities to solve, rationalize the denominators. It says find the sine of theta given that the cotangent of theta is -1/3 and theta is in quadrant 4. Okay, so I'm thinking about cotangent. I want to look for an identity that involves cotangent. My first thought is to use this one. Okay. That way I can relate it to the cosecant, which can then relate it to the sine. That may not be the only way, but that's kind of what I'm thinking of, so I'm going to try that. Let's move this up a little. Okay, so I'm going to put in, let me jot it down real quick. All right, so the cotangent is -1/3. The cotangent squared plus 1 is equal to the cosecant squared. When I square this is going to be 1/9. So if I want to add it to 1, nice and easy, let's rewrite this 1 as 9/9. I can do that because those are equal, right? And now I have a common denominator to make the fraction work a little easier. So this is 10/9. Okay, why don't I go ahead and take the square root, so I just have the cosecant instead of the cosecant squared. So if I take the square root of both sides, I can take the square root of the denominator, so really this is like the square root of 10/3. Okay, now I kind of skipped over something, and I'm going to go back and add it in, and then we're going to talk about it in just a minute. So when I take the square root of both sides, technically there's a plus or minus there, right? So it could be a positive or it could be a negative. When I've done, I'm going to use this piece of information here to decide, right, whether it's positive or negative. Okay, the cosecant is 1 over the sine, right? And so to get the sine, I really am going to take the reciprocal. We could finagle all this around, but I'll save us that work, okay? So this kind of implies that the sine of theta is going to be the reciprocal. We're also asked to rationalize the denominator, so let's go ahead and do that. So if I multiply top and bottom by the square root of 10, I'll have 3 square root of 10 over 10. Okay, and if I go back to that piece of information that we wanted to add in at the end, right? If I am in quadrant 4, what sign does the value of the sine have? In this quadrant, right, the cosine is positive, but the sine is negative. So I really want to choose the negative value for the sine. All right, so while we could have drawn a triangle and worked out all the sides of that triangle, we could have done it that way, right? In this chapter, we're practicing using the identities, so we're solving it in a different way, but again, you could do it both ways. Also in this section are some, they're not identities yet, we're just kind of taking some expressions and rewriting them with sine and cosine and kind of preparing for verifying identities, which is the next chapter. Okay, so the directions say write each expression in terms of sine and cosine and then simplify. I feel like these are kind of like a puzzle. I kind of like these. They're kind of fun for me. I hope that you find they're the same. All right, so really all we're doing is we're trying to use sine and cosine to start out. That's one good technique that you can use when verifying identities. It's definitely not the only technique, but it's one of them. So the cosecant of theta times the cosine of theta times the tangent of theta. Let's rewrite the cosecant of theta as 1 over sine of theta. Cosine is already fine the way it is. And let's rewrite the tangent of theta as the sine of theta over the cosine of theta. Okay, now we're going to go ahead and put this cosine over 1. Now we can simplify. If we were to multiply these straight across, right, we'd have one cosine and one sine in the top, one cosine and one sine in the bottom. So really, these are going to divide to be 1 or cancel out. We're really just going to be left with 1. Okay, so we took something that looked very complicated and made it much, much simpler. And that's kind of what we're going for here. Let's try another one. Let's do the same here. Let's write this. Actually, we may not even need to write this in terms of sines and cosines. Before we do that, let's just go ahead and do what we would algebraically and distribute. So we'll have cotangent squared of theta plus cotangent squared times tangent squared. All right, I'm pretty sure that we can make this simpler. So this is cotangent squared of theta. Now you could go for sines and cosines, or you could use the reciprocals. I'm going to use the reciprocals this time because I think that's a little more direct. Both would work just as good. Cotangent is 1 over the tangent, so these are going to divide out or cancel. And we're going to be left with cotangent squared of theta plus 1. I think we have an identity for that. If you look back to your Pythagorean identities, this is the same as the cosecant squared of theta. So we made that as simple as possible. Let's try a couple more. I think we could use algebra for this one as well. This is number 70 from your book. We have the sine of theta minus cosine of theta, in parentheses, multiplied by the cosecant of theta plus the secant of theta. Let's use FOIL to multiply this out. So we'll do the first times the first. And even though we could probably simplify it right away, I'm going to do it piece by piece, so I'm going to write it out first. Then the outer, so plus sine of theta times the secant of theta. Then the inner, so minus cosine of theta times the cosecant of theta. And then the last times the last, minus the cosine of theta times the secant of theta. All right. Okay, now let's go ahead and use sines and cosines just so it's really clear. So we'll have the sine of theta. The cosecant is 1 over the sine of theta. We'll have the sine of theta times the secant, which is 1 over the cosine. Then we'll have the cosine times the cosecant, which is 1 over the sine, minus cosine times 1 over cosine. All right, these are going to cancel or divide out to be 1. The sine of theta divided by the cosine of theta, that's really the tangent. The cosine of theta divided by the sine of theta, that's really the cotangent. And then these cosines are going to divide out to be 1. And now we have 1 and minus 1. So these are going to add to 0 or cancel out. So we're left with the tangent of theta minus the cotangent of theta. And that's about as simple as we can make it. I picked these examples just to kind of give you a taste of all the different types of strategies and techniques, and we'll develop those further as we go along. How about one more? This time we have 1 plus tangent squared of theta divided by 1 plus cotangent squared of theta. This really makes me think of the Pythagorean identities. So if you flip back to those, we had 1 plus the tangent squared of theta was equal to secant squared of theta. And 1 plus the cotangent squared of theta was equal to the cosecant squared of theta. Okay, if we go back to kind of what we started with on these and we rewrite it with sines and cosines, we get this sort of complex fraction, which is okay. The secant is 1 over the cosine, and the cosecant is 1 over the sine. If I'm dividing fractions, I can do that keep, change, flip idea. So I keep the first fraction, change the operation to multiplication, and flip the second fraction. So that's going to give me sine squared of theta over cosine squared theta. And that's a quotient identity for tangent squared theta. All right, well, I hope this gave you a taste of the fundamental identities and kind of what skills we're working on as we go through this chapter and kind of get ourselves ready to verify identities of various types. So this will definitely take some practice. Don't be afraid to look for some practice problems to help you try this out for yourself. This is a very creative process, so it's going to take some time for you to kind of be comfortable with the identities and where you can fit them in. Good luck, and we'll see you in the next video.